Hello guys, welcome, greetings from wherever you are watching. We are continuing with the next part, that is number 2, term number 2. So term number 2, without wasting much time, let us begin our lesson. So that one was knowledge approximation and errors. So what made me to give this subtopic the name? Why did I only choose to term it knowledge approximation and errors? Now listen, this is a type of approximation and errors that requires the knowledge application of formulas. You must have that knowledge. You must know. You must have that idea. You must have it at the back of your mind. The knowledge or the formulas that are used in the particular questions under this subtopic, which we shall do. Now, leave alone that. Remember, I've just said that these are type of approximation and errors that requires the knowledge application of formulas. In short, you must have the formulas for you to solve this topic. Now, there are two formulas of solving absolute error on and given number, and we've just started. There are some terms you will come across in this topic. Absolute error. Absolute error. You will come across some terms in this topic, that is approximation and errors. And the number one term we are looking at is absolute error. Now, we can get absolute error in various ways. Way number one, for individual number. For individual number. For individual number. What do I mean like for individual number? For example, 1, for example, 1, 4.263, 1.03, 9.835. These are individual numbers. These are individual numbers. You can get absolute error in these individual numbers. Are we together? So, for individual number, guys, remember for individual number. Now, to get absolute error for individual number, you will have a half 1/2 multiplied by smallest unit that has been used in calibration. That has been used in calibration. Now, for a physics student, he or she will understand this. But what if I'm not doing physics? Then have it this way. absolute error is equal to a half times accuracy. I will tell you. Remember these two, they means the same thing. Okay. Now, what is an accuracy in a number? What is an accuracy in a number? For example, number 1. What is the accuracy in 1? The accuracy is 1. What about number 2? 2. What is the accuracy in 2? It is 1. What about 3? What is the accuracy in 3? It is 1. Now, leave alone these. These ones are easy. And maybe you are still wondering, I'm still not getting it. Now I have this. What is the accuracy in 4.23? The accuracy in 4.23 is 0.01. So that accuracy is 0.01. What about 1.0? What is the accuracy in 1.0? The accuracy is 0.1. So that means our accuracy is 0.1. What is the accuracy in 3? Accuracy in 3 is 1. What is the accuracy in 9.835? The accuracy is 0.001. So the accuracy there is 0.001. That is the accuracy in a given number. So you must understand that 1 is not the same as 1.0. 2 is not the same as 2.0. Only that concept is only applicable in the topic of approximation and errors. It is only this topic that will tell you that 1 is not equal to 1.0. 2 is not equal to 2.0. Have that one in your mind. Now, I hope you can now give accuracy in various numbers. Like for example, if I have 1 million, remember this 1 million is a whole number. For a whole number without any decimal, the accuracy will always be 1. For a whole number that is containing decimals, then it shall be treated according to the way it appears. Like for example, for instance, our accuracy in 1000.000, the accuracy will be 0.000. Sorry. The accuracy in 1000.00 will be 0.001. That one will be the accuracy in 1000. How about 1 million? 1 million point 0.0000. The accuracy there will be 0.0001. I hope up to that point you can now get the accuracy for an individual number. I hope up to that point you can get an accuracy for an individual number. For example, how about giving you 3.53? What is the accuracy in 3.53? The accuracy is 0.01. All right. Let's move from that point. Let's take on something. So this one was our part A. This one was part A, absolute error, part A for individual number. Absolute error, part A for individual number. Remember, you must know how you can get sorry. Before we continue, I was just giving you an accuracy. That one was accuracy. Now, for you to get absolute error, it is a half multiplied by that accuracy. Okay? It is a half multiplied by that accuracy. Now, for instance, let me use this. Let me use 3.53. Let us have some example. 3.53. I'll use 9.835. 9.835. I'll use 3 and 1.0 together with 4.23. Now let me use these examples. So in the case of 3.53, what is the accuracy? We've seen there that the accuracy in 3.53 is 0.01. That means the absolute error in 3.53, it is a half. I multiply by 0.01. So having that in your calculator is what? A half multiplied by 0.01. That one is giving us 0.005. Now, this is the absolute error in 3.53. That one is done. How about 9.835? 9.835. We've seen that 9.835 has an accuracy of 0.001. That means the absolute error in 9.835, it is a half multiplied by 0.001. The work of a calculator, a half multiplied by 0.001 is giving us 0.0005. Now, what about the other number? So the absolute error in 9.835 is 0.005. Let's check on another number, that is 3. The absolute error in 3, guys, is what? Is 1. The accuracy is in 3 is 1. That means the absolute error will be a half multiplied by 1. A half multiplied by 1 giving us what? 0.5. 0.5. Let's check on other number. We have 1.0. 1.0. The accuracy in 1.0 is not 1. Rather, it is what? 0.1. So the absolute error will be a half multiplied by 0.1. A half multiplied by 0.1, which will be 0.05. Let's check on the last one, that is 4.23. 4.23. The accuracy there is 0.01. The absolute error is a half multiplied by 0.01, giving us what? A half multiplied by 0.01, giving us 0.005. 0.005, guys. That is it. Now, an examiner will not just ask you to get absolute error. Rather, the examiner will want you to get the maximum absolute error and the minimum absolute error. So, if it is a maximum absolute error, you will add that given absolute error to the previous number. Now, for this case, 4.23 is our previous number. So, if the examiner wants me to get the maximum absolute error, I'll have 0.005 plus 4.23, the initial number. If the examiner wants me to get the minimum absolute error, then I'll have 4.23 subtract the given or our absolute error, which is 0.005. But before we move on to that part, let us check part B. Part B of absolute error. That is part A, how one can get absolute error. Now let's check part B. Absolute error is given by the formula maximum value minus minimum value divided by 2. This one, you must have it in your mind. Now, where is this applicable? This is applicable for general numbers, for combined numbers. For example, when the numbers are combined, like you're having a 2.23 plus 4.6. This is now not individual number. This is a combined number. And when the numbers are combined this way, part B, absolute error equal to maximum value minus minimum value divided by 2 is what we shall use. But before we check on that, let us have the other term. The other term you will come across with in this topic is relative error. Relative error. Relative error is also called fractional error. Fractional error. So do not go into an exam room, then you find a question asking you, get the fractional error of the given number. Then you're like, what is this? What is this? This is a new part, this is a new thing. No. So, relative error is also called fractional error. So, how do we get relative error? Which formula is being used? You take absolute error divide by actual value. Relative error or fractional error is given by absolute error divided by actual value. Absolute error divided by actual value. Another term which is common in this part is a percentage error, and we've looked on this. Percentage error. Percentage error is also present in knowledge approximation and errors. Now, percentage error is given by relative error multiplied by 100%. But in some cases, you will be told that percentage error is the same as having absolute error all over what? All over actual value. Actual value you multiply by 100%, which is still the same, which is still correct and the same. Remember, this has been condensed to relative. So it is relative error you multiply by 100%, or you have absolute error over actual value, which still refers to relative error. Then you multiply by 100%. Now listen. There's a note which I won't write down, but you listen. No question an examiner will set for you that requires the knowledge of formulae part A, because it is 1 mark. What was our part A? What was our part A? Let me just take you back. Our part A was absolute error for individual number. Absolute error for individual number. Let me repeat my note. No question an examiner will set for you that requires the knowledge of formulae. This part A. Why? Because it is always 1 mark. 1 mark. A paper 2, you will never find a 1 mark question. Ukipata pengine ni bahati yako. Okay. Let us move to something new. Let us move to something new. Okay. Under this topic, I want you to get me clearly now. We are now in a very, very delicate part of this topic, and you must pay attention at your maximum. Now listen. Under this topic, addition and multiplication, subtraction and division have different methods or ways of calculating absolute error. Remember, I've read them in pairs. I've read addition and multiplication, addition and multiplication. Then we have subtraction and division. Subtraction and division. This is pair 1. This is pair 2. Whatever I said, I've said that under this topic. Which topic? The approximation and errors, addition and multiplication, subtraction and division. They have different methods or ways of calculating absolute error. The approach or the procedure of getting absolute error in addition and multiplication will differ from the procedure or the process that I will use to get the absolute error when it comes to subtraction and division. Those process will differ. Getting absolute error in the two are much different. They are different. Now, I want to scare you a bit, but not that much. The big problem with this topic is always to get absolute error. And if you can manage to get absolute error, then nothing will be difficult for you. The only big problem is to get absolute error in some questions. Remember, we are still under the subtopic number 2, which is knowledge, approximation, and errors. And this part, knowledge, approximation, and errors, I told you it is very large. It is very large. So, let us check on something new. How to get absolute error. Let me abbreviate it as AE. Absolute error under addition and multiplication. What does this one tell you? What does this tell you? That addition and multiplication, they have the same procedure of getting absolute error. Addition and multiplication goes in hand using the same procedure, the same formulae of getting absolute error. Let me just repeat myself from what I've noted down here. Now, both addition and multiplication share common method when calculating the absolute error. The procedure for arrival to the answer are the same. the procedure, that process for arrival to the answer are the same. Now, let me start with multiplication. Let me start with multiplication. Multiplication. Then we have the following the following question, and the question reads: Amina multiplied 35.61. Amina multiplied 35.61 and 5.6. What was the absolute error in Amina's multiplication? What was the absolute error in Amina's multiplication? As a student of mathematics, you must be very neat. You must organize your work in a very attractive manner. That even if your answer is wrong, but the way you've arranged your work is attracting. That neat work sometimes always impresses some examiners, and they will just give you a trick. So let me give you that trick. Let me give you that trick. Procedure on how to arrange your work. To arrange your work. Don't just do mathematics because people are doing. Don't just do mathematics because it is an exam period. Don't just do mathematics because you are doing it to get the marks, or you are doing it because it is the protocol. Okay. Procedure on how to arrange your work. At the far end of your left hand, have min or min, stand for minimum. At the middle, have actual. Then at the far end of your right hand, have max, which stands for maximum. Now, what is the actual number? We were told Amina multiplied 35.61 and 5.6. Those are the actual. So arrange them here. 35.61, 5.6. Remember when we started, I told you how you can get absolute error for individual number. So whatever I'm doing here is not like I am copying somewhere or I am reading a book from somewhere. No. No. I told you how we can get absolute error for individual number. And I can remember telling you that when examiner will want you to get maximum, you add. When examiner will want you to get minimum, you subtract. Though we never wrote that one. We never tackled that part. I only said it. But the part we tackled, the part we did was 35.61. We can get the absolute error in this number. So let us do that. Let us get the absolute error in 35.61. So what is the accuracy? So doing that one, you will have to do it at the margin of the page, or just find a space somewhere and do it. If you are in an exam room, so just find a space and have it done. So what is the accuracy in 35.61? The accuracy there is 0.01. You multiply by a half to get what? To get absolute error. So having 0.01 multiplied by a half is giving us 0.005. This is our absolute error. But now we want to get the maximum and minimum. So let's get the maximum. So I told you to get the maximum, you add. So you take 35.61 plus 0.005, which is our absolute what? Error. So under maximum, For 35.61, we shall have 35.615. 35.615. So how about the minimum? So take 35.61, subtract 0.05. 0.05, we shall get 35.605. 35.605. Let us come to 5.6. Let us come to 5.6. The absolute error in 5.6 is 0.1. You multiply by what? By a half. You multiply by a half. So 0.1 multiplied by a half is giving us 0.05. This is the accuracy, and together with it, we have the absolute error. So take 5.6, add to 0.05 to get the maximum error. So here we shall have 5.65. 5.65, and on this other side we shall have 5.6 minus 0.05, having 5.55. Having 5.55. Remember, I told you the working or the calculation, you do it at the margin of your book, or maybe find a space to do your calculation. Guys, if you have something like this, your work will look neat. Your work will look organized. Your work will look attractive. And the examiner will just give you marks. Just a tick. 3 marks, 4 marks. Yet you've just done a slight mistake. But because you've arranged your work neatly, you are getting the mark. Now, remember, this was multiplication. You don't have to indicate whether you are multiplying or adding. The question already specifies that this is a multiplication thing. The question itself already specifies that this is a multiplication thing. So down here is what we shall write. Or maybe at this other far end, you can just indicate multiplication. At the far end of your right hand, you can just indicate the multiplication sign, the X. Now, so let's multiply. Under the maximum, let's multiply 35.615 multiplied by 5.65. What are we getting there? Just write everything. 201.22475. How about 35.61 multiplied by 5.6? We are getting 199.416. How about minimum side? 35.605. You multiply by 5.555. So we are having 197.60775. Remember, I told you, if you look at this thing, this is a combined number. And I gave you the formula for getting absolute error when it comes to a combined number. So absolute error, when it comes to a combined number, we add our maximum value minus minimum value divided by 2. Now, what is our maximum value? We have it here. So it is 201.22475 minus the minimum value. We have it here. That is 197.60775. If we subtract, we get the absolute error to 1.22475 minus that. We shall have our answer as then divide by 2. After subtracting, divide by 2. Yeah, we shall have our answer as, so this divide by 2. So that one divided by 2, we shall now get our answer as 1.8085. And that is our absolute error. Now, what if it was addition? What if it was addition? Let's check on addition. Let's check on addition. Remember, things are just done directly. After getting the maximum and the minimum, you just multiply them directly. This multiplied by this multiplied by this. That much straightforward. Now, let's check on this example under addition. Odhiambo added 8.65 and 5, and 3.7. Odhiambo added 8.65 and 3.7. What was the absolute error in Odhiambo's addition? Odhiambo added 8.65 and 3.7. What was the absolute error in Odhiambo's addition? This one is a combined number. So if it is a combined number, you know the formula to use. So first of all, arrange your work. We have the actual, the maximum, and the minimum. So the actual, we have 8.65 and 3.7 and 3.7. So what is the accuracy in 8.65? That is 0.01. After let me tell you, if you do more revision, these things you won't have to be noting them down again. You will just look at the number, you can see the accuracy, and by then you can get the absolute value or the absolute error in that particular number. Like for example, for instance, 8.65, by just looking at the number, the accuracy there is 0.01. Then to get the absolute error is 0.05. So we add. So take 0.05, add it to 8.65 to get the maximum error. So 8.655. Then if you subtract 8.65 minus that 0.05, we shall have 8.645. How about 3.7? The accuracy is 0.1, the absolute error is 0.05. So if I add 3.7 plus 0.05, I get 3.75. And if I subtract that, I get the on the side of the minimum, I have 3.65. Now, after doing that, just indicate at the far end there that we are adding. So add them directly, going downward the way they are. So under maximum column, we shall have 8.655 plus 3.75. That one giving us 12.405. Under the actual 8.65 plus 3.7, we shall have 12.35. Now, under the minimum, we shall have 8.645 plus 3.65, having 12.295. So now after getting those, or after getting the calculation, we can now get the absolute error. And remember, absolute error is maximum value minus minimum value divided by 2. So what is our maximum? 12.405. So 12.405 minus the minimum 12.295. Then we divide by 2. So have that in your calculator. 12.405 minus 12.295 divided by 2. Our answer will be 0.055. Now, the same procedure for both addition and multiplication is not the same procedure we will apply when calculating the absolute error in division and subtraction. I hope you will do more examples under addition and multiplication. But still, we haven't covered that that more concept that we had to, because we are still in the process of summarizing the topic. We shall do the revision when the right time comes. So guys, when we meet in our next lesson, we shall tackle the part how to get absolute error. Let me abbreviate this as AE. How to get absolute error under subtraction and division. So I thank you for watching. Kindly subscribe, share, and also invite other friends, because knowledge is all about sharing. Knowledge is never kept alone. Thank you once again. Let us meet in the next part.